Reciprocating engine power cycle. In the previous chapter, we discussed power cycle incorporating either steady-state process or piston cylinder boundary work process. There are two types of steady-state or piston cylinder boundary work process. In that section, it was noted that for the steady-state process, there is no work in a constant pressure process. Each of the steady-state power cycle presented in subsequent section of each chapter. That chapter to this point in the present chapter incorporated two constant pressure heat transfer process. It should be noted that in a boundary work process, for the two constant heat transfer process, W equals to Z. It should be noted that in a boundary work process, W equals to PdV. There is no work at constant volume. In the next four sections, we will present ideal a standard power cycle for piston cylinder boundary work process. Each of example which includes either one or two constant volume heat transfer process. Before we describe the reciprocating engine cycle, we want to present a few common definitions and terms. Car engines typically have 4, 6, or 8 cylinders, each with a diameter cut or the diameter of cylinder. Let me provide a picture for more description. Each with a diameter of B or the piston is connected to a crankshaft as shown in the picture, and as it rotates. Change the crank angle theta, the piston moves up or down with a stroke. The length of bevel stroke to radius of crankshaft. This radius or crankshaft. This gives a displacement for our cylinder as volume of displacement and number of cylinder V max minus V min, and cycle number of cylinder multiply the area of cylinder multiply to a stroke. Which is the main characteristics of the engine size. The ratio of the largest to the smallest volume is the compression ratio. Ratio between V max and V min compression ratio RV CR V max on V min, and both of these characteristics are fixed with the engine. These are fixed. The net specific work in a complete cycle is used to define a mean effective pressure. So till now we have this relation for a reciprocating engine, V displacement, and cycle, V max, RP, and the displacement we have this compression ratio CR, compression ratio equals to V max on V min. The net positive work in complete cycle is used to define a mean effective pressure. P mean effective. This is definition, the work W net direction cyclic P TV P we mean. Or network per cylinder per cycle network per cylinder per cycle and this is a multiplication P mean effective multiplied to P max this is a specific value. We now use these to find the rate of work for the whole engine as W dot end cycle mean effective V displacement multiply to RPM on 60 rate of work for the whole engine. Number of cycles multiply to the mass burned multiply to W at positive network PM mean effective is obtained with this relation. RPM on 60 where RPM is revolution per minute. This result should be corrected with a factor of 1 second for a 4-stroke engine where 2 revolutions are needed for a complete cycle to also accomplish the intake and exhaust stroke. 4-cylinder W dot 1 second of a number of cycle and W dot net RPM on 60. Most engines are 4-stroke engine where the following process occurs: the piston motion crank angle in a 4-stroke engine for a stroke engine. We have also this specification according to this picture. Intake at first top dead center, P constant, and V increase. Compression one set, bottom top set center to top dead center 0, excuse me, V decrease, P also P increase, and T increase. Ignition and combustion. Fast top dead center, V constant, Q in, T and P increase. Expansion one set, top dead center to bottom dead center, V increase, P decrease, T decrease, and Q 0. Exhaust, bottom top center to top dead center, flow up. Notice how to intake and exhaust process each takes one whole stroke. Intake and exhaust process each takes one whole stroke. Of the piston. So 2 revolutions with 4 strokes are needed for the complete cycle. With 4 strokes are needed for complete cycle. In a 2-stroke engine, the exhaust flow starts before the expansion is completed, and the intake flow overlap in time with part of exhaust flow and continue into compression stroke. This reduces the effective compression and expansion process, but there is power output in every revolution and total power is nearly twice the power of same size 4-stroke engine. Two-stroke engines are used as large as so these are for 4-stroke, 2-stroke, engine. This has flow start, before the expansion is completed. And the intake flow overlap in time with part of the exhaust flow. Part of exhaust flow and continue into the compression stroke. This reduces the effective compression and expansion process. Perfect. But there is power output in every revolution and the total power is nearly twice the same. But the power output in every and the total power is nearly twice the power of the same size. Four-stroke engine. Two-stroke engines are used as large diesel engine in ships and a small gasoline engine for lawn mower and handled power tools like weed cutters. Using large diesel engine in ships. and small gasoline engines such as the weed cutters or lawn mowers and etc. Because of potential cross flow from the intake flow to the exhaust port, the two-stroke gasoline engine has seen reduced use and it cannot conform to modern low emission requirements. For instance, most onboard motors that were formerly two-stroke engines are now made as four-stroke engines. The largest engines are diesel engines using both stationary application as primary or backup power generator and two-stroke engine high emission exhaust emission. And the next, the largest engines are diesel engines used in both stationary application as primary or backup power generator and in moving applications for transportation industry as in locomotive and ships. Used in the stationary application such as backup power generator, and in moving application to transportation industry and or moving applications such as locomotive and ships. A remote location. An ordinary steam power plant cannot start by diesel and thus could have a diesel engine to power its instrumentation and control system and so on to make a cold start. A remote location on land or a drilling platform at sea also would use a diesel engine as a power source. Trucks and buses also use diesel engine due to their high efficiency and durability. They range from a few hundred to perhaps 500 horsepower. Ships use diesel engine running at 100 to 180 RPM, so they do not need a gearbox to the propeller. This engine can even reverse and run backward without a gearbox. The world's biggest engine is a two-stroke diesel engine with a 25 meter cube displacement volume and 14 cylinders, giving a maximum of 105,000 horsepower using a modern container ship. The auto cycle is the next section.